So what if it's not a special angle? So what if I give you some information and I'm asking you to find the trig functions, but it's not a 30, 60, 90. It's not a 45, 45, 90. Can we do it? Of course we can. Okay, so pardon me. For example number 1, it gives us 2 pieces of information. It gives us the sine, and we can see right away that the sine is positive. And then we're given cosine, which is negative. So if we think about a Cartesian coordinate plane, in the first quadrant, all the trig functions are positive. Second quadrant, sine and its reciprocal. Third quadrant, tangent and its reciprocal. And then fourth quadrant is cosine and its reciprocal. Okay, so we need to figure out first, it doesn't really matter what theta is. We know theta is our reference angle, and we're given some side ratios. We need to find out where it lies on the Cartesian coordinate plane so that we can then draw our triangle and find the remaining 4 trig functions. Okay, so since sine is positive and cosine is negative, we're definitely not in the first quadrant. In the fourth quadrant, cosine is positive. Whew, well, that doesn't work. Okay, in the second quadrant, sine is positive. That's most likely where we're going to have our theta. But let's check the third quadrant, tangent is positive, so sine and cosine are both negative. So now we know we're going to be in the second quadrant. Pardon my cough again. If we were to draw that triangle in the second quadrant, okay, so here's our x and y axes, just so we can get some sort of frame of reference, okay? And we're going to draw that triangle. It always, if I'm in standard position, extends out from the origin and down to the x-axis. Theta is at the origin. Okay, so we know that sine is 3/5, which means it is the opposite leg over the hypotenuse. And then cosine is -4/5, so that means that the adjacent leg is -4 and the hypotenuse is 5. And this checks out if you think about the x and y axes in the second quadrant. X-axis is negative, so that leg is -4, so that makes sense. And then we have the opposite leg going up, which means it would be positive units in the positive y-axis, and it is. And then our hypotenuse is distance, and it's positive. Okay, so finding, we've got sine, cosine, we need tangent. Tangent of theta is opposite over adjacent, so that would be -3/4 based off of our drawing. The other 3 are the reciprocals. Cosecant is the reciprocal of sine, which means it is hypotenuse over adjacent. Adjacent, what? Hypotenuse over opposite. So it's 5/3. Secant is the reciprocal of cosine, so that means it's going to be the hypotenuse over the adjacent. There's that one. Okay, so -5/4. And then cotangent of theta is the reciprocal of tangent, so it's adjacent over opposite, which means it's going to be -4/3. So there is what was asked for the other 4 trig functions. Sweet. Okay, well, let's try it again. So here, we're given tangent and cosine. So I'm going to draw my Cartesian coordinate plane. All students take calculus. I know, not everyone does. Okay, tangent's positive and cosine is negative. So since one of them is negative, the first quadrant's out. The second quadrant, sine, is positive only. So yeah, definitely not happening there because tangent and cosine would have to be negative, both of them. And then in the fourth quadrant, cosine's positive, which we know it doesn't happen. So we are in the third quadrant. Why? Because tangent would be positive, cosine negative. All right, so we're going to draw our triangle. If you guys don't want to draw the x and y axes, you don't have to. I'm just doing it as a frame of reference so we can see how to draw the triangle because that's super important. So we extend out from the origin and always go back to the x-axis. Theta is at the origin. Tangent. Tangent is opposite over adjacent. So it would be opposite over adjacent. But we know that we're in the third quadrant. So both the 5 and the 12 have to be negative, seeing that we would go left on the x-axis and then down for the y-axis. Cosine. Cosine is adjacent over hypotenuse, so adjacent we already have, and the hypotenuse is always positive. So there's our triangle. Find the remaining 4 trig functions. All right, we've got tangent and cosine. We are missing sine. The sine of theta, which is our reference angle. Sine is opposite over hypotenuse, so this would be negative 5 over 13. We have cosine and tangent. That was our given. The reciprocal of sine is cosecant, so the cosecant of theta is hypotenuse over opposite, which is going to be negative 13 over 5, the reciprocal of sine. Secant is the reciprocal of cosine, so that's hypotenuse over adjacent, which is going to be negative 13 over 12. And then cotangent is the reciprocal of tangent, so the cotangent of theta is going to be adjacent over opposite, in this case 12 over 5. So there are the other trig functions. Yes, cotangent would be negative 12 over negative 5, but negative over a negative means that it would be positive, and we don't write negative over a negative. It's not simplified form. Okay, last example. Here we're given some different information. The terminal side, okay, so that's the end of the rotation around the origin. If a terminal side of an angle passes through a point of a circle, 8, negative 15, find all trig functions. Okay, so if I am the coordinate 8, negative 15, that means I have traveled positively for my x coordinates and negatively for my y coordinates, which means I am in the 4th quadrant. Let me switch colors real quick. Those of you that are like, yeah, I don't need color. Yes, you do. Color's fantastic. Okay, so we go over 8 units, so 8 units, and down negative 15 units. And there is our point, negative 8, 15. We always connect back to the origin, and our reference angle is at the origin always. Okay, now, in order for us to be able to find all 6 trig functions, we need the hypotenuse. Is it a special right triangle? Maybe. Some of you are probably thinking, I don't remember those. Okay, well, if you don't remember, we can always use the Pythagorean theorem. So we're going to say that 8 squared plus negative 15 squared is going to give us, in this case, I'll use r because r is, our radius of the circle. It says through a point on a circle, so we can use r. You could also use c squared since that's normally what we use for the hypotenuse. It is totally up to you. Okay, so we get 64 plus 225 is equal to r squared. If we were to add those together, we get r squared is equal to 289. Is it? Why, yes, ladies and gentlemen, I do think it is. I'm going to double check with my calculator. R is 17. And some of you are like, duh. Well, yes, special right triangle, but just to make sure, you can always use the Pythagorean theorem. Here we go, 6 trig functions, sine of theta. Now, if you want to name the angle alpha or beta, that's fine. I always use theta. That's the most common. So the sine is opposite over hypotenuse, negative 15 over 17. Cosine of theta is adjacent over hypotenuse, so we get 8 over 17. And tangent of theta is going to be opposite over adjacent, so negative 15 over 8. 6 trig functions. The regular, the normal, the usual, right? Sine, cosine, tangent, and the reciprocals. So cosecant of theta is the reciprocal of sine, which means it is hypotenuse over opposite, negative 17 over 15. Secant is the reciprocal of cosine, so that means it is hypotenuse over adjacent, or 17 over 8. And then cotangent of theta is the reciprocal of tangent, which is adjacent over opposite, negative 8 over 15. And that, ladies and gentlemen, is how you figure out trig functions for angles that are not quote-unquote special angles, or 30, 60, 90, 45, 45, 90. It's just process of elimination. Figure out what quadrant you're in. Make sure that the legs match if they should be positive or negative. Theta, your reference angle, is always at the origin, and you're rocking from there. All right.